All right, looking at this one now, it's two sections that we're putting into one. Geometric sequences and series. So we're going to be looking at uh, um, sequences and series, but not arithmetic like what we talked about previously, but we're going to be looking at them geometrically, which is slightly different. We're still looking at like repeating numbers or numbers that go after each other, but we're going to look at geometric instead of arithmetic. So geometric deals with a common ratio. Okay, you're going to multiply or divide by something. Okay, that's what you're going to be doing. So if you remember in arithmetic, what we did was we added or subtracted the numbers to see. Now this one, we're going to see if there's a single number that we keep multiplying by to get it. Now to find it, what you're going to do is you're going to take the second number and divide it by the first. So 15 over 5 gets you 3. Then the next one you're going to go 45 over 15. That gets you 3 again. And then if you do it again, it gets you 3 again. So our common ratio for the first one would be 3. Okay, we took the second number and divided it by the first. So now if we look at the next one, it'll be 33 over 99. And that gets us 1/3. Okay. And if we go 11 over 33, we get 1/3 again. So what we have here is that we have another common ratio, but it's a fraction. Okay. And you see it's less than 1. Okay. So that's your common ratio. So you just keep dividing by the second number by the first number, seeing what you get. Okay. That's geometric. So the formula to find any term in a geometric sequence, okay, once you know what the ratio is, you go a of n, which is whatever term you want to find, is equal to the first times the ratio to the power of the term you want minus 1. So if we look at this one, okay, we want to find the 12th term for 8, 16, 32. Well, 16 to 8 is 2, 32 to 16 is 2. So we know the ratio is 2. Okay. A1, our first term, is 8, and then our n would be 12. So when we set this up, it's going to be A12 is equal to 8 times 2 to the power of 12 minus 1. So it would be 2 to the 11th times 8. And then we would take the exponent first, so we go 2 to the 11th first, and then multiply it by 8. And we end up getting about 16384 as our number. So the 12th term is 16384. Okay? Pretty simple, right? So it's just kind of plugging into the formula and seeing what you get. Okay? So that's to find any term in a geometric sequence. Okay, geometric mean. So if you remember previously, we talked about arithmetic mean, which arithmetic mean is where you add the two together and divide by 2. Geometric is different because you're going to multiply the two numbers together, and then after you multiply them together, you're going to take the square root of them. So the square root of the product of the two numbers. So if you're given two numbers in a geometric sequence, and you're told, okay, this is the first one, this is the third, find the middle one, you would use a geometric mean. So here we're told, okay, here's our sequence. We've got 20, some number, and then 80. So what we're going to do is we're going to do the geometric mean. So we're going to go 20 times 80, and then we're going to take the square root of it. 20 times 80 is 16, 0, 0, square root. That gets us about 40. Oh, no square root. So that means that this number would be about 40 by taking the geometric mean. Okay. If it doesn't come as a nice round number, keep it in radical form, so simplify the radicals. But otherwise, let's simplify it if you can, if it comes down as a nice round number. So that's the geometric mean. Okay. So the geometric mean deals with multiplying and then taking the square root. All right, series. So now, previously when we talked about arithmetic series, we're adding those two together. And geometric series, we're doing the same thing. We're adding them together and seeing what we get. Okay. Now here's the formula for this one. If you remember in arithmetic, the formula for it, we needed, it was S of n is equal to n over 2 times a1 plus an. So we needed whatever term it was. For a geometric series, we don't need the last term. All we need is the ratio and the first number. So if we're told here, we go, okay, here it is, 4, 16, 64. We got to find the ratio. 16 divided by 4 is 4. 64 divided by 4 is 4. So we know that the r is 4. Okay. Now, once we know that the r is 4, our a1 is 4. So we're going to plug it in. A of 7 is equal to 4 times 1 minus 4 to the 7th all over 1 minus 4. Now, when we calculate this through, we end up getting our answer of about 12844. 21,844 is our answer, calculating it through. Okay? So again, it's just plugging in the right things and then finding what you have. Alright, so what we have now is that we're going to be looking at an infinite series. So if you remember in arithmetic we cannot add infinite series, so numbers that it never ends. Geometric series we can, because a cool thing about a geometric series is that it does something called it will converge. Okay, it will converge onto 0, which basically means that if we took this series right here, we go 1 and then we go 1/5 and then we get smaller and smaller, and as you see we get closer and closer to the x-axis, or closer and closer to 0. Okay, that's called a converging series. Okay, now if the number keeps getting bigger, so if it goes like that, that's called a diverging, and we cannot find it. So if your ratio is a fraction and it's less than 1, so like 1/3, 2/3, 9/10, any of those, you can find the infinite series of those. But if it's greater than 1, so if it's 2, 3/2, anything more than 1, you're not going to be able to find it because it goes off infinitely. Okay. Then we're talking about absolute value of these. So if you get a negative 1/3, you can find the sum of that. It's still less than 1 absolute if you were to take the absolute value of it. Okay. So if you had -7 as your number, as your ratio, that cannot be, because that's more. If you take the absolute value of -7, it's 7, which is more than 1. And so it just keeps getting bigger and bigger and bigger. Okay, so infinite series here. When you do this one, okay, all you need is the first term, and you need the nth, and you need the ratio. Okay, so the sum of an infinite series, what you're going to do is you're going to take the first term, plug it into the top, and then you take whatever your ratio is. In this case, it's 1/5, and for the r. So we'll go 1 over 1 minus 1/5, and then we would solve it. Okay, we would calculate it through. So you'd want to find the denominator and then go 1 over that. And for this one, we end up getting about 1.25. Okay, now and that would be the sum. So if you added up every single one of these numbers as it got smaller, 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 it would go to 1.25. Okay, that's just what it would be. Now, if this ratio was more than 1, so let's say it was 2. Okay, so if we went from 1 and then 2 and then 4 and blah, 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 so on and so forth. So that means our first term is 1, and then underneath it'd be 1 minus our ratio, which is 2. Okay. One minus 2, which would be 1 over a -1, which, as we can see, that doesn't make sense. It can't be, our sum total can't be -1 when we keep getting bigger and bigger and bigger. Okay, so that's why we're going to have to, that's why you can't have one that's greater than 1. Okay, because as you see, your sum here is actually should be less than that number. Okay, so you've got to make sure that your ratio is less than 1. All right, so looking at this one, we've got we got 3, 1, 1/3, and then 1/9, and so on and so forth. So our common ratio here would be 1/3. Okay. If you divide the previous from the one before, it's always 1/3. So that means our R is 1/3, and our A1 is 3. Okay. So now we plug it into our formula. It'd be 3 over 1 plus, nope, not plus, 1 minus 1/3, which gets us 3 over 2/3. And then we would solve that, and we end up getting our answer of about 4.5. Okay. So 4.5 would be the sum if you add up all these together. Okay. And as you see, if we get the first couple, we're already pretty close to that. But if you think about it, now you divide. Now next one would be 1 over 27, and then keep it smaller and smaller. So the number keeps getting smaller as you keep going, and it just doesn't get close to what we're supposed to get. So the sum here would be 4.5. So all you do is you just plug it into the equation and then find it. All right, your IRAT. Find the geometric mean of 52 and 64. Okay, just keep it in radical form. So find the geometric mean of those. And the next one, evaluate the series. So for the first 11 terms in this geometric series of 3, 6, 12, blah, 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 blah. So find the ratio, and it has an endpoint, okay? So you're going to use the one that uses the one with the endpoint. So the A1 equals 1 minus R to the nth all over 1 minus R. Okay, you're going to use that equation. And your N here is 11.